Okay, well, I want to welcome Dr. Julie Pigza, an organic chemist in our School of Mathematics and Natural Sciences in the Chemistry Biochemistry discipline. Dr. Pigza is going to talk with you today about some of the research opportunities that she has and projects in her laboratory. And so, Dr. Pigza, I'm going to turn it over to you.
Yes, thank you, Dr. Masterson. Hello, students. I know some of you from 106S, so now you get to see the research side of things as well. I mainly organic synthetic chemist, so we make compounds, and then I also do organocatalysis, which is using small organic molecules to facilitate reactions. And so I'll just use my cursor to show you here. The first strategy using organocatalyst, we want to form products that are enantiomer, meaning they have one specific orientation, and we use the term R or S to signify those two orientations. Having one orientation is important for medicine that you're taking, for example. The orientation or stereochemistry can determine its properties or side effects. And so being able to make just one product is important. And to do that, we need control over the reaction conditions using what are called organocatalysts. And so that's shown on the right in black. This is a SQ catalyst, which stands for squaramide. The catalyst is what is known as chiral, and so it can impart that chirality and direct the formation of product during a reaction. So this reaction we've developed in the lab, we're combining this reagent in blue and the substrate in red, and you can see that we form the bond between the two in the presence of the squaramide catalyst, and the bond is drawn thick, and so that is a wedge coming towards us. Alternatively, it could be going away from us, and that would be the other product. And so we favor just this product, and that's due to what's shown in brackets. The catalyst helps orient both substrates to attack such that we get just one face that this substrate in blue adds to the substrate in red and gives us just one product favored. And so these dotted lines are facilitating the reaction, and they're called non-covalent interactions. And there's energy values associated with those. And so we're interested in developing reactions to form just one product. And we're also interested in studying the energy of those interactions. And I have listed here that the program we use is called Gaussian. It's installed on a supercomputer that we have at USM. And anyone can use that. And so we can submit jobs, as they're called, to the supercomputer and help to understand these reaction pathways so that we can develop new catalysts and new reactions. And I have two other products shown in the middle of the slide for other projects we're interested in. Students in my group learn organic synthesis techniques and handling compounds. And then all compounds we make, we have to prove the structure, and so we use what's called NMR, nuclear magnetic resonance spectroscopy, and IR as our main techniques, and so you'll be trained in those techniques as well. On the top right, you see the NMR is the little instrument. It looks small, but it's actually taller, about probably 6-7 foot tall, and we run our samples in there. I encourage my students to present their work. So in the bottom right of the slide, you can see students give poster presentations. Students apply for awards and funding. And I just work with students as a whole as part of being a student in my research group. So that's all. Thank you.
Thank you, Dr. Pigza. A couple of questions that students might have for you. If you were actually in the class during a normal semester, might be something like, at what point in their undergraduate career do you typically take students into your lab to conduct research?
Yes, since my research relies heavily on organic chemistry, I think it's important that students enjoy organic chemistry. And so you really we'll find that out when you're in CHE 255 in your sophomore year. So students who are in 255 and enjoying the material they learn, that would be a good point to reach out to me to let me know that you're interested in my lab. And we can arrange opportunities like shadowing, where you shadow students in my lab to see if you know what the techniques are like and what the day-to-day is like, and you can ask questions of students, and then that could lead to you signing up for a research course with me the following semester when you're in Organic 2.
Okay. So how would a student, if they were to come and talk with you and ultimately join your research program, how would they be incorporated into that lab at the beginning? Would they be given a project of their own, or would they be kind of working with somebody on a project? How does that typically work for undergraduate students who are new to your lab?
Yes, that's a good question. So in my lab, students have their own project regardless of what level they're at, whether they're new or not, and you are paired with either a more experienced undergraduate student who's been in the lab or with a graduate student. And you usually contribute, so you have a portion of a project that one of those students are already on. So for example, in the middle of the slide, I have that reagent in blue called mask acyl cyanide, and in red. Both of those need to be synthesized. And so usually new students would start by making the materials needed for reactions. You're doing steps over and over again and learning the techniques in the lab, which is important. And then once you're more experienced, then you can go on to like the more involved projects. But you always have your own project. So if you were synthesizing a substrate shown on the slide, you would be able to present, like make a presentation on that research with a table of all the substrates that you've made.
Okay. Well, fantastic. So I'm assuming that the best way for a student to get in touch with you would be simply by your email if they were interested in pursuing opportunities for research with you?
Yes, that's the best way.
And you can see that she has placed her email address there on the slide. And so we're encouraging students who might have an interest in this type of work or in organic chemistry in general to reach out to Dr. Pigza for research opportunities. So Dr. Pigza, I want to thank you again for your time with our Chemistry 108 students, and I know they're going to find what you did interesting.
Yes, thank you.
You're welcome.